Hi. Today we're going to talk all about Kepler-22b. It's an exoplanet, that is, a planet outside our solar system. It was confirmed by NASA's Kepler mission in 2011. It is in the habitable zone of its star, the so-called Goldilocks zone where liquid water could exist, if other conditions allow. Radius about 2.38 times the radius of the Earth, according to measurements. Mass, not well known. There are estimates of up to 36 times the mass of Earth in some models. Composition may not be rocky like Earth. There is a chance that it is an ocean world, a lot of water, or has a significant volatile layer, gas or liquid, that is outer. Equilibrium temperature estimated at about 262 K according to some models, if there is no very strong greenhouse effect. Orbit and star system. Kepler-22b orbits the Sun-like star Kepler-22, yellow dwarf. Orbital period, approximately 289.9 days. That is, it takes almost 290 days to make a complete revolution around its star. Distance from the star, semi-major axis, about 0.849 AU, astronomical units, according to some data. Orbital eccentricity, it is very low according to some estimates, or at least it is not known precisely. Host star, Kepler-22. Spectral type, G, similar to the Sun. Surface temperature, lower than the Sun. In some measurements, 5,596 K for Kepler-22. The star has a lower luminosity than the Sun, which helps make the habitable zone closer. Habitability and potential for life. The presence in the habitable zone suggests that liquid water could exist, which is essential for life as we know it. Because it has a very large radius, more than twice that of Earth, it can have a thick atmosphere. This can cause a greenhouse effect or other conditions that greatly alter the climate. It is not known exactly if it is totally rocky. If it is very volatile, it could have deep oceans or even a gaseous layer, which would greatly change the type of possible life. The possibility of moons around Kepler-22b that could be habitable was also studied. A study by the Hunt for Exomoons did not find a moon large enough for some hypotheses, but this does not completely rule out that there was a smaller moon or one with special characteristics. Mysteries and limitations of what we know. Uncertain mass. Without a well-measured mass, it is not possible to know the density accurately, which makes it difficult to infer the actual composition of the planet. Whether it's rocky, oceanic, or gaseous is debated. Each hypothesis greatly changes the type of environment there could be. Atmosphere. We have no confirmation of what the atmosphere looks like, if it exists, how dense it is, what gases make it up. Actual temperature. The equilibrium temperature is an ideal calculation. If there is a greenhouse effect, the temperature can be very different. Exomoons. The search for moons on Kepler-22b has had no decisive result. If there are any, it could greatly influence habitability. Direct detection. Like many exoplanets, we can't see their surface or take a realistic picture. We rely on indirect methods, transit, brightness variation, etc.